Hey, welcome to The Explainer. Today, we're diving into one of the most powerful concepts in programming, higher-order functions. We're going to see how they help you write code that's smarter, not harder. You know that feeling, right? You write a piece of code, then you write another one that's almost the same, and then another. It's a total headache, but guess what? There's a much more elegant way to handle it.
So take a look at this. On the left, you've got the old way, the clunky way, a separate function for every single greeting. But now look at the right. One single, clean function that actually builds the other functions for you. That, right there, is the magic of what we're talking about today. And it's all possible because of higher-order functions.
So, what exactly is this powerhouse tool we're talking about? Well, think of it like a master craftsman. But instead of just doing a job, it literally builds the tools that do other jobs. Okay, so here's the textbook definition, but don't let it scare you. It's actually super simple. A higher-order function is just a normal function with a kind of superpower. It can treat other functions like they're just pieces of data. It can take a function as an input or spit a brand new function out as its output. Seriously, that's the whole deal.
All right, let's break that down. First up, taking other functions as arguments. This is like handing your function a set of instructions, another function, and telling it, hey, run this, but only when you're ready. You'll hear this called a callback all the time.
Okay, check this out. We've got this function, process user input. Instead of hard-coding what to do with the user's name, we just pass in the greet function as an instruction. Our main function holds on to that instruction, waits for the input, and then calls back to our greet function with the name it got. And the really cool part? We've totally separated when something happens from what happens. It's incredibly flexible.
Okay, so that's one half of this story. Now for the other side. And this is where, honestly, my mind was kind of blown the first time I got it. Functions can also return brand new functions. This is where we get that awesome function factory idea.
And this phrase really hits the nail on the head. You're not just calling a function to get a simple value back. You're using a factory to build a brand new, totally custom tool made to your exact specifications. Let me show you what I mean.
Okay, let's make this real. Look at this multiplier factory. When we call it with the number 2, we're not getting a number back. No way. We are getting a whole new function. A specialized little machine that is now permanently set up to multiply anything you give it by 2. We've just created a custom double function.
And this is where the light bulb really goes on. We can now use our new double function whenever we want. And we can go right back to the multiplier factory to make a triple function or a quadruple function. That one factory is reusable, and all the little tools it makes are reusable. It's just so much cleaner.
Now the best part? You don't have to build all of this stuff from scratch. JavaScript comes standard with these amazing pre-built machines, a whole set of higher-order functions ready for you to use, especially for working with arrays.
First up, you've got .map. Think of map like a transformation assembly line. You give it an array, and you also give it a function that tells it how to change each item. It then runs every item through that function and spits out a brand new array with all your transformed items. Here, we're turning every number into its square.
Next in the toolkit, we have .filter. This is your bouncer, your quality control inspector. It looks at every single item in an array and runs a test that you provide as a function. If the item passes the test, it gets into the new array. If not, it's out. Here, our test is the number even? So only 2 and 4 get to stay. And then there's .reduce. This one's like the final assembly station. Its job is to take a whole bunch of parts, your entire array, and combine them all down into one single final product. In this case, we're telling it to just add everything up, and it reduces the entire array down to the number 15.
Once you get comfortable with these ideas, these factories and callbacks, it opens up some really advanced but super cool techniques, like currying. It's basically taking a function that needs a bunch of arguments at once and breaking it down into a chain of functions that each take just one argument. It's like a specialized factory line where each station adds just one ingredient before passing it down.
Okay, theory is great, but let's get our hands dirty. It's time to put on your architect hat. You've seen the tools, you get the concepts, so let's tackle a few quick challenges.
All right, first challenge. You've got an array of words, but what you really need is an array of their lengths. We need to transform each word into a number, right? That sounds like a job for .map. Boom, one line, super clear, job done.
Okay, next up. We've got a tile of numbers, but we only want the ones that are greater than 10. We need to select or filter our list. That's a dead giveaway for, you guessed it, .filter. We give it our test, and it gives us back a new, cleaner array.
And now for the big one, the final challenge. Let's have you build your own function factory. This makeAdder function takes one number and returns a completely new function that's preset to add that number to anything. And just like that, you're not just using functions, you're building them.
All right, so let's zoom out and pull it all together. The big idea with higher-order functions is that you can treat functions like any other variable. You can pass them into other functions as flexible instructions. We call those callbacks. You can have functions that return new, specialized functions. We call those factories. And you should absolutely use the amazing built-in tools like map, filter, and reduce. All of this leads to code that is way cleaner, easier to read, and so much more reusable. So, look, this is way more than just some abstract coding trick. It's a whole different way to think about solving problems. It's about building with small, smart, reusable Legos instead of big, clunky custom blocks every single time. So I'll leave you with this question. What powerful function will you build first?